Hello everyone, this is Mr. Voikin, and congratulations on your last test. And these are the level 6-7 study questions that will prepare you for the next test level. Okay, so let's get started on question number 1. So we're going to be using BEDMAS to calculate the following. So first we're going to look for brackets. 29 times 2 is going to be 58. Now at that point there are no more brackets. We have a negative 2 in the bracket, but we can't really do anything to the negative 2. So the brackets are done. Next we're going to move on to exponents. So there is an exponent right here. So we need to take the cube of negative 2, and that's basically negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. And we still have to multiply it by negative 2, and a positive 4 times negative 2 is a negative 8. So we'll bring this one down to a negative 8 right there, and that we can keep the brackets around there. That way we can just pop these sort of signs and the rest of the numbers back into there. Okay, so the exponent is done. Now we're going to move on to division and multiplication. So do I have any division and multiplication? Yes, I have a 6 times negative 8 right here. Okay, so I'm going to do that first. So 6 times negative 8 is a negative 48. So this is a negative 48. And so it's going to be 4 minus 48 plus 58. All the division and multiplication is done. Now we're down to the last step, which is just addition and subtraction. And we'll just do that starting on the left here and moving to the right. So 4 minus 48 is going to be a negative 44. Add 58 to that and we're going to get a positive 14. And that is our final answer. Okay, we're moving on to question 1b, which is also going to be BEDMAS. So I've written it down over to the side here so I can just make sure I'm following those steps. So let's take a look at the brackets. Well, in this case, we have two sets of brackets right here. So I've got this square bracket right here, and then inside that, I've got these normal brackets right here. So we're going to go to the innermost bracket. Now, when we look inside that innermost bracket, there's a few things going on. There's subtraction and multiplication. So I need to use BEDMAS inside the bracket as well. So multiplication comes before the subtraction, so we're going to do that first. So inside those blue brackets right here, I'm going to do 4 times 7, which is 28, and just put the rest down like that. 3 minus 28 is going to be a negative 25. Okay, and I'm just going to keep that again inside the bracket. And then I'm just going to put everything back together just so I'm not missing anything. Okay, and this goes right here. And whoops, I obviously missed that little 5 that was supposed to go in there. Okay, and right now I'm still inside those brackets. These were those green brackets that were up top, so I don't need to write everything down at this point. I'm just going to finish off with my brackets. So negative 25 divided by 5 is going to be a negative 5. And again, I could just keep those in the brackets right there until we're done. Now let's bring everything else down. So I'm going to bring down this negative 1, so that's negative 1 times negative 5. On the other side of the bracket, it's minus 2 times 24 divided by 6. Okay, so brackets are done. Cross that off. Are there any exponents? No. And now we're on to division and multiplication. So I'm going to take a look and get that done. And again, I'll just sort of go left to right. So you can see right here, I've got this one, which is a negative 1. Times a negative 5, which is going to be a positive 5. Okay, minus 2 times 24 divided by 6. Okay, so in this case, what I'm going to do is I'm going to tackle this 2 times 24. Okay, so 2 times 24 is going to be 48, and I'll bring everything else down. Okay, so do I have any more multiplication and division? Yes, I've got this one right here, which is 48 divided by 6. 48 divided by 6 is going to be 8, and I'll bring over this minus 5. So now I've got 5 minus 8, which is going to equal negative 3, and that's our final answer. Okay, and on to question 1C, another BEDMAS question, and again we can see we got some complex arrangement of brackets. So I like using the colored pens just to find the opening bracket and its closing bracket down there. From there I can go inside. I've got this negative 3 that's inside that bracket, and I have another one right here, a 5 plus 6 that's inside these square brackets. So to start, we're going to go into the green brackets. And now that we're in the green brackets, we're still doing BEDMAS again. Are there more brackets? Yes, there's more brackets. So the negative 3, I can't do anything with that. That's just separating that number from the operation. But I can go into those orange square brackets right there and do the 5 plus 11. So, or sorry, 5 plus 6, which is 11. And again, I can just keep those inside the bracket for now. Go plus 25, that's going to bring this squiggly bracket there. 3 minus, and a minus 6, and a squiggly bracket. Everything, the 89 right now, I don't have to worry about that because we're dealing with everything inside the brackets right now. So are there still more brackets inside those squigglies? Yes, but they're just separating the numbers. So brackets are sort of done on the inside, but we're still inside the brackets, so technically we're there. So now that we're inside these green brackets, that's what we're working on right now, we're going to see if there are exponents. No, there are no exponents. Is there division and multiplication? Yes, I've got a negative 3 times an 11. Okay, so negative 3 times 11 is negative 33. And again, I'll just sort of keep that in a bracket, and everything else is going to come down. Okay, so on these complex questions, it's just important to go slowly and step by step so that you don't make mistakes, especially at the beginning when you're learning. Okay, is there any more division and multiplication? No. So now I'm going to go to addition and subtraction, and again, I'm just going to go left to right. So I've got a 6 minus negative 33. So 6 minus negative 33 is the same as 6 plus 33, which is going to be 39. So again, I'll keep that in the brackets right there. I'm still inside that squiggly, plus 25 inside the squiggly, and 39 plus 25 is going to be 64. So I've got a 64 that were inside those squiggly brackets. Now I got to remember, don't forget to bring this stuff down right there. So I have an 89 plus 64. So an 89 plus 64 is going to be 153, and that will be our final answer. Okay, moving on to question 2. Looks like we have a percentage question, and we're going to be comparing somewhere. I see the word comparison and ratios. So we're going to be dealing with ratios, comparing things, and some percentages. So let's get started. We'll grab a highlighter and pull out the important information to begin with. So we have this boy named Johnny. He's got 20% of 200 and happens to be marbles. And Susie has 60% of the same 200 marbles. So in the classroom, there's 200 marbles. Johnny grabs 20% of them. Susie grabs 60% of them. And we're asked to compare what percent of Susie's marbles does Johnny have. Okay, well, first thing we're going to need to do is take a look at the number of marbles that Johnny has. So if I take 20% of the 200, that basically breaks down to a 0.2, times the 200. And if I do this over to the side, we can see that that is going to be 1 decimal point. So Johnny has 40 marbles. And Susie has 60% of the 200. So if I do this as well, she's got 60% of the 200, which is 0.6 times the 200. And if I do 200 times 0.6, we're going to get 0012 with 1 decimal place. So we know that Susie has 120 marbles. So if I compare them, and I want to know how many Johnny has in comparison to Susie. So Johnny has 40 in comparison to Susie's 120. So now it says, well, what percent is that? Well, what I'm going to do is I'm going to break this down to its lowest fraction form. So I can knock off a 0 right there, and I have 4 over 12. I recognize that I can divide 4 into both those numbers, so I'm going to end up with an equivalent fraction of 1 over 3. So now that actually answers the last part, which is right here, asking what is the ratio of Johnny's marbles to Susie's marbles. So the ratio would be this, and I'll write it out in word response. The ratio of Johnny's marbles to Susie's marbles is 1 to 3. Okay, and that would be the answer to the second part of that question. And now we just need to figure out the percentage. So this is one of those numbers that you should recognize. 1 over 3 is 33.3%. So again, in a word response, Johnny has 33.3% of the number of marbles compared to Susie. And that would be the answer to the first part of the question. So even though he has 20%, only has 20% of the 200 that are in the class, he's got 33% in comparison to Susie's 120. Okay, question 3, we've got another percentage question. So again, to the highlighter, let's pull out the important information. So we got a bag and we have 500 objects in there. Happen to be popsicle sticks. And we got one student, Steve, he takes 20% of the sticks. We got another student, Mary, she takes 50% of those sticks. Alex takes 10% of the sticks, and then poor little Jack, he's left at the end wondering if there's going to be enough sticks for him. He needs 100. So will he need to buy any more, and if so, how many? Okay, well, let's start off with Steve. Okay, so Steve is going to take 20% of the 500. So we know that we can take the 500 and multiply that by 0.2. That is going to be 1,000. Move the decimal over one space because the one decimal place right here. So we know that Steve has 100 popsicle sticks. And what about Mary? Well, Mary takes 50% of the sticks. So 500 times 0.5, she's going to take 250 of those sticks. Okay, and the last person that's taking sticks before Jack is left to see how many are remaining is Alex. And Alex is going to take 10% of them. So 500 sticks times 0.1. You don't even really have to do the math here. You should be able to do some mental math and know that 10% of the 500 is going to be 50 sticks. So altogether, I'm just going to erase this 1 0 here. We got Steve with his 100 sticks plus Mary's 250 sticks plus Alex's 50 sticks. So how many sticks do we have remaining? Or sorry, how many sticks did they take? They took 400. How many did we start with? 500 sticks. How many are remaining? 100 sticks. So how many does Jack want? He wants 100 sticks. So the answer is going to be Jack does not need to buy any sticks because there is still 100 where are you going? Going back, remaining. And there is our final word response to our word problem. Okay, question number 4. It says we have a rectangular field and the long side is 200 meters and the short side is 0.1 kilometers. So the first thing you want to notice here, and it's really important, that we don't have the same units. So for the length, I've got meters, and for the width, I've got kilometers. So what I need to do is put them all to the same units. And if you actually look at the last sentence, which usually tells us what we need to do, they want the answer to the area of the field, but in square centimeters. So we're basically dealing with 3 different units here. So I think at the end of this document, I did give you a small little data sheet that's showing you how to convert units. It gave you the numerical value to 2 decimals for pi, how to calculate the area of a circle, and how to calculate the volume of a circle. So I'm just going to take this one right here and see if I can just copy that and paste it up top there. Take screenshot and we'll upload that. We'll just copy it. Okay, and let's go see if this works. Nice if it does. Where are we? Right here. All right, let's paste that in there. Beautiful. Okay. So in this case, I'll put everything to meters for my first calculation, or I can change it all to centimeters. Actually, that makes a little bit more sense. So let's draw out this field first of all. So I've got a field that I know is rectangular, and the length is 200 meters. So we're going to take the 200 meters and we're going to convert that to centimeters. Okay, so I will look at here where we're at, base units, that's meters. And I'm going to centimeters, means I need to take the decimal 2 spots to the right. So if I take this 2 spots to the right, I'm going to go from here 1, 2, and I'm going to fill those areas in with zeros. So I'm going to have 200 and 2 more zeros. That's going to be centimeters. So this is 2 like that. So 20,000 centimeters. And for the width on the short side, it's 0.1 kilometers. So we have 0.1 km. And where are we going to? Centimeters again. So we're starting here on the km and we're going 1, 2, 3, 4, 5 jumps. So which means I'm going to take that decimal 1, 2, 3, 4, 5 jumps that way. And I'm going to end up with 1, 0, 0, 0, 0 centimeters. Okay, so this is 10,000 centimeters. So we have a field that is 20,000 centimeters long by 10,000 centimeters wide. And how do we calculate the area of a rectangle? It is length times width. So essentially all we have to do is go area equals length times width. Now, it looks like a big calculation, but it's actually really easy to do here. All we have to do is just multiply the 2 times the 1, which is 2. And then I'm going to count the number of zeros that there are. Just add every one of those zeros. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm literally going to have 1, 2, 3, 4, 5, 6, 7, 8 zeros, and the units will be centimeters squared, and that is our final answer. Okay, question number 5, moving along, another word problem. So what does it say? So Susie here, I'm going to pull up my highlighter, has a right triangle. So that's important information because we know that one of the angles is going to be 90 degrees. Okay, and it says it has a base of 32 centimeters, and that's the bottom of the triangle, and a height of 24 centimeters. And it's also important to note that they have the same units. So I don't have to do any unit conversion here. The teacher asked her to draw a similar triangle that has 3 times, oh no, I am going to have to change some units because they're asking for the answer in square millimeters right here. Okay, so that is going to be important. I need to get everything into millimeters. So that, what are we doing here again? Draw a similar triangle that is 3 times larger than the first triangle. What is the area of the triangle in square millimeters? Okay, so let's start off with a triangle to begin with. And it's a 90-degree right triangle. The base is 32 centimeters and the height is 24 centimeters. And it says we're going to have a new triangle that is 3 times larger. So basically, I am going to have a new triangle here that is going to be 3 times larger. So I just need to multiply 24 by 3. We get 2, 1, we get 72. So this is going to be now 72 centimeters. And the base is 32, and we're going to multiply it by 3. So we get 96 centimeters. But again, make note that we're going to be converting to millimeters. Now, centimeters to millimeters is quite an easy conversion. All you're going to do is move the decimal 1 place to the right. So the new answer is not going to be, is going to replace the centimeters with 720 millimeters. And we're going to replace the 96 centimeters with 960 millimeters. Now, what are we trying to calculate here? We're trying to calculate the area. So the first thing you need to know is what is the formula for the area of a triangle. Well, area equals base times height divided by 2. So the area is going to be base 960 times the height 720, and then I'll divide that by 2. So you're going to have to start by multiplying 96 times 72. So 96 times 72 is going to be 2, 1, 18, 19, 0, 42, 4, 63, 67, 2, 1, 8, 9, 6. And don't forget, I didn't add in these 2 zeros right here. So it's just a quicker way to do it. And now I can add those 2 zeros right there. So we've got 0 and 0. So the area is going to equal 691,200 divided by 2. So now you're going to have to do that math somewhere off to the side here again. So I've got 6. Let me just see if I can move a few things out of the way here. Reduce the size. Put it up here. Okay, so let's try this. Be careful when transferring numbers all over the place that you copy it down correctly. 691,200. We're going to divide 2 into there. 2 goes into 6 3 times, and it goes into 9 4 times. It goes into 11 5 times. It goes into 12 6 times. And then the other ones will just be 0 and 0. So the answer is going to be 345,600. And the units were millimeters, and because it's area, it needs to be squared. Okay, question number 6. We have a rectangular prism, and it gives us some information about it. It has a length of 40 meters, a width of 25 meters, and a height of 10 meters. So I've got all my dimensions, and they're all in the same units. That is good. So I'm going to start off by drawing the rectangular prism. Okay, and that looks good enough. And we've got 40 meters for the length, I've got 25 meters for the width, and I got 10 meters for the height. Okay, now it says in the center of this rectangular prism, so right in the middle of this, there's a cylinder cut out of it. So that's basically means there's a hole that's sort of cut out of this thing all the way through. Okay, so I have a cylindrical hole right here that's cut all the way through, which means it's going 10 meters down. And this is important, it has a radius of 5 meters. So this right here has a radius of 5 meters. And all these units are also meters, so we're doing good. So what am I trying to figure out? Well, I want to know what is the volume of the object in cubic meters. So the object is going to be that rectangular prism minus the hole. So the volume of the object equals the volume of the rectangular prism minus the volume of the cylinder. So we'll start off here with the volume of the rectangle. That one's quite easy to do. So it's going to be volume of the rectangle equals length times width times height. So the volume of the rectangle is going to be 40 times 25 times 10. And we'll start off by doing 40 times 25, and I'm going to get add a 0, 22, and 8, 9, 10. Okay, so I have 1,000 times 10, and that's an easy calculation to do in your head. The volume of the rectangle is equal to 10,000 meters cubed. Okay, so I'm just going to minimize this a little bit, get it out of the way, create some more space. Okay, and now what about the volume of the cylinder? Well, we know that the volume of the cylinder is equal to pi times the radius squared times the height. So the volume of the cylinder is going to equal 3.14 times, what's the radius? 5. 5 squared is 25 times the height, and what is the height? 10. Okay, so we'll start off with this 3.14 times 25. So 3.14 times 25. It's got to do some math right here. So 20, 2, 7, 15, 0, 8, 2, and 6. So we get 0, 5, 1, 8, and it's going to be 78.50, but don't forget we have 2 decimal places here, so I need to have 2 decimal places here, and that means we're going to place a decimal right there. So really what we have here is 78.5 square meters. Okay? So all I need to do now is subtract those. So I'm going to have 10,000, the decimals right there, and minus 78.5, and I'm going to subtract those two. So I'm going to have to borrow from here and basically end up with 9999.10. Subtract the 5, we get a 5. 9 minus 8 is 1. 9 minus 7 is 2. And 9 and 9. So the final answer is going to be 9,921.5 cubic meters. Okay, on to question number 7, and we're going to be doing some algebra and solving for x. And I don't know why I wrote x, because in there is an a. So in this case, really what we're going to do is solving for not necessarily x, but the known. In this case, the variable happens to be a. So remember what we want to do. We want to get all the variables on the left side of this equal sign and all of the numbers on the right side. So on the right side, notice that we have this that we need to expand by using the distributive law. So 6 times 5a is going to be 30a. And 6 times 4 is 24. And now on the other side, I've got a negative 11 minus 5a. So again, here's our equal sign, and let's start moving the a's to the left and just the constants to the right. So I'll start with this 11. So because there's a negative 11, I'm going to add 11. That's going to cancel those, so that becomes 0, so it's no longer there. But to keep things balanced and equal, if I add 11 to the left side, I need to add 11 to the right side. So now what I'm left with is negative 5a's equal these 30a's plus 35. Okay, so what about these 30a's? Well, I want those 30a's over on the left side. So I'm going to subtract the 30a's. I've got rid of them. Again, keep things balanced. If I subtract 30a's on the right side, I need to subtract 30a's on the right side. So, or sorry, the left side. So now what do we have left? Well, I've got negative 35a's over here, and that equals 35. Now the last step, I need to separate sort of the a's from that negative 35. So I don't want to know what negative 35a equals. I want to know what 1a equals. So how do I, what calculation or process do I need to do to have 1a on the left side? Well, I'm going to divide by negative 35, and that means to keep it balanced, I'm going to divide by negative 35. Okay, I'm just going to move this over a little bit, so we have some more space. Okay, and when I divide on the left side, negative 35 divided by negative 35 is just my a value of 1a. I just don't write that. And 35 on the right side divided by negative 35 is negative 1. So the answer is a equals negative 1. All right, question 7b. Same type of thing. We're going to solve for the unknown, solve for the x, and there's our equal sign. So again, we want our variables, or the x's, sort of over on the left side, and we're going to want our numbers over on the right side. So we're going to expand everything out at first, just like we did before. So 8 times 1 and 8 times the 5x. So let's just expand this all out and then move things left and right, and finally solve for the unknown. So 8 times 1 is 8. 8 times 5x is 40x plus our 5. Our equal sign is right there, and we got 13 plus 5x. Okay, so I'm going to start by moving these constants over. I have an 8 and a 5 on this side, so total constants that I have is going to be 13. So I've got a plus 5, a plus 8, so I've really got 13 on this side. So I'm now going to subtract 13 from this side, which means I'm going to subtract 13 from that side. And you can see in this case, they both get canceled out. So what we're left with is 40x equals 5x. Now it looks a little strange at this point because you're like, well, where's the constant? What's going to be left on the right side when I move that 5x to the other side? Well, if I subtract the 5x from the right, I have to subtract 5x from the left. On the left, it's easy to see that we have 35x. And what do we have left on the right-hand side? We have nothing. And what is nothing? It is 0. So now I don't want to know what 35x is equal. I want to know what 1x equals. So if I divide 35 by 35, I get the value of 1x. And I have to keep things balanced. So if I divide by 35 on the left, I divide by 35 on the right. And 0 divided by 35 is 0. And that is it. Okay, question 7C, same thing, solving for the unknown, just getting a little bit more complex. So the first thing I'm going to do is find out where my equal sign is. And again, I'm going to get all the variables, the x's on the left and all the numbers on the right. And I need to expand on both sides in this case. So 5 times 2 is going to be 10x. And 5 times 6 is going to be a positive 30. My equal sign is right there. And now you got to be careful here. Don't forget there's a negative in front of this 4. So don't miss out on that. It's a negative 4 times a negative 5. So I have a positive 20. So I've got 20 right here. And a negative 4 times a negative 2x is going to be a positive 8x plus another 3x's that were already outside of that. Okay, so I can sort of collect like terms on either side. So right now I've got 10x plus 30, and we did this in the last one where we collected that 8 and 5 that were both constants on one side. In this case, I've got this positive 8x and positive 3x on one side, so let's put them together. So this is going to be 20 plus 11x. Okay, so just like we've been doing in previous ones, let's move the constants over to the right. I've got a positive 30, so I'm going to minus 30 from both sides. That's gone here, leaving me with only 10x's. And what do I have left? Well, I've got negative 30, a positive 20, so I've got negative 10s. I still have that positive 11x over there. So what am I going to do? Subtract 11x, and that's going to cancel that. Keep things balanced by subtracting 11x. And what do I have left? I've got a negative 1x equals negative 10. Okay, but it looks like we're almost done because there is a 1 in front of the x, but it's not a 1, it's a negative 1. So I want it to be a positive 1. So what am I going to do? I'm going to divide it by itself. That becomes a positive 1. So now I do have x equals. Keep things balanced. If I divide the left by negative 1, I divide the right by negative 1. And negative 10 divided by negative 1 is a positive 10, and that is our final answer. Okay, here we go. Question number 8. We're going to be using BEDMAS again, except in this case we're dealing with some fractions. Okay, so we're going to start off with the B. Are there brackets? Well, yes, there are. We've got a bracket and a bracket right here. So we go into that bracket and we're going to go right back. Are there any more B's in there? Are there any more brackets inside those brackets? No. Are there exponents? Well, there is an exponent out here, but remember, we are inside the bracket right now. So we're not going to deal with that quite yet. We're going to deal with what's inside the bracket first. Okay, so there are no exponents inside the brackets. So next we're going to move to division and multiplication. So there is some division right here, which is going to be the 3/8 divided by 3 over 4. So I'm going to rewrite that as 3 over 8 times the 4 over 3. Okay, now you should note here that the 3 can be canceled down to 1 because there's another 3 here on the bottom. And the 4 up top, I can divide 4 into there 1 time, and I can divide 4 into 8 2 times. So what I'm actually left with right here is just a 1 over 2. So I'm going to rewrite this with my bracket here. Keep the be careful. The 2 over 5 there, and plus what? Plus the 1 over 2. That's what's inside the brackets, and later we are going to square that. So we're still inside the brackets, but now I have some addition to take care of. So 2 over 5 plus 1 over 2, they do not have the same denominator, so I need to get a similar denominator. So a common denominator in this case is going to be 10. So multiply the 5 times 2, I get 10, so I need to multiply the 2 by 2, and I get 4 up top. And multiply the 2 by 5 to get 10, so I'm going to multiply the 1 by 5 to get 5. So what we actually end up with inside those brackets is 9 over 10. Okay, so now what do we have? Well, we have 9 over 10, and we are going to square that. Okay, so basically when we square this, we're just going to square the top number, the numerator, and square the bottom number, the denominator. So 9 times 9 is going to be 81, and 10 times 10 is 100. Okay, and that will be our final answer because there isn't a common factor that can divide into both 81 and 100. Okay, here we are on question 8b. We got a fractional bed mass question again. So I'm just going to write down bed mass. And there are some brackets right here, so we're going to jump into there to begin with. So 7 over 12 times 9 over 10. And I can see right here that I can divide 3 into 9 and get 3, and divide 3 into 12 and get 4. So that simplifies it a little bit. And now on the top I've got 7 times 3, which is 21, and on the bottom I have 4 times 10, which is 40. Again, I'll keep those in brackets, then bring everything else down. Okay, now I'm done inside the brackets. There are no exponents, and division and multiplication, we don't have any of that either, so we're on to addition and subtraction. And again, we're just going to do that in the direction left to right. But I'm going to be adding or doing eventually first the subtraction, then the addition. And I notice here that I do not have the same denominator in any of them. I got a 10, a 40, and an 8. So what is a common denominator for all three of those? And that would be 40. So we're going to rewrite this with a common denominator. So something over 40 minus something over 40 plus something over 40. So the first one, 10 to 40 is times 10. So 9 times 10 is 36. For the middle one, it's already at 40, so that's just going to stay at 21. And for the last one, from 8 to 40, that was times 5, so 3 times 5 is 15. Okay, so let's start off with, like I said, this first part right here, the subtraction. So again, I know my answer is going to be over 40, and 36 minus 21 is going to be 15 over 40. Plus the 15 over 40. Okay, and we're just going to sort of move it up and over here. We're running out of space. So again, my answer is going to be out of 40, and 15 plus 15 is 30. Now 30 over 40 is not in its simplest terms. We can cross off a 0 off each of those, and we're left with 3 over 4, and that will be our final answer. Okay, let's take a look at number 9. So it says, again, we've got another right angle triangle. So we know that it has an angle of 90 degrees. And it says right here that one of the other angles, a second angle, is 40 degrees. And what about the third angle? Well, it says it's not indicated, which means it's unknown. So let's draw that to begin with. So I have a right angle triangle. We know that one side is 90. And any of these other sides, doesn't matter which one I choose, it's going to be 40 degrees. And this angle right here that I'll call X is unknown. So angle X is going to equal 180 degrees minus the 90 degrees that's already there, minus the 40 degrees that's there as well. So we have angle X coming in at 50 degrees. Okay, let's move to the second sentence of this word problem. It says there's an isosceles triangle. Now, if you don't know what that is, it's a triangle that has two angles and two sides that are the same. And it even states that right here. It says it has two angles that are the same. Same as what? Same as the unknown angle of the right triangle. And that's this 50 degrees right here. So basically what I have is another triangle like this. And these two angles down here look similar, and they're going to be 50 degrees each. What is the value of the third angle? Well, I know that all three angles are going to equal 180 degrees, so I've got my angle that I'll call y here, give it a different variable. So y is going to equal 180 degrees minus 50 degrees minus 50 degrees, and so y is going to equal 80 degrees. And that would be your final answer. And again, because it's a word problem, you'd usually answer this with a word response. So the third angle of the isosceles triangle is 80 degrees. Don't forget to put your units, or else it's technically not correct. Okay, here we are on the last question. That's for some reason called 10A, not just 10. And we're going to be using BEDMAS again. The first couple of BEDMAS questions were using integers. Then we moved into BEDMAS with fractions, and now we've got BEDMAS with decimal numbers. Okay, so we're going to go to the B. Are there any brackets? Yes, there's one set of brackets right here. So we need to go into those brackets and call up BEDMAS again. Are there any brackets inside the brackets? No. Are there exponents inside there? No. Is there any division and multiplication? Yes, right there. Okay, so basically what the first operation we're going to do is 6.5 times 8.2. So off to the side, I'll do 6.5 times 8.2. And 2 times 5 is 10, 12, 13, 0. That's going to be 40, carry the 4, 48, and 52. So we got 0, 3, 3, 5. Now don't forget we have two digits behind the decimal, so I need to, in my answer, I need to have two digits behind the decimal. So that ends up being 53.3. So right here, this is 53.3, and I'm still inside here, so basically I have 4.3 plus 53.3. And again, I'll do this sort of off to the side. Well, I don't really need to for numbers this small. So I could do it off to the side and stack them if you want to be extra careful. So 53.3 plus 4.3. Remember, it's important that we line up these decimals right there when we're adding and subtracting. So 3 plus 3 is 6. There's the decimal, continues to line up. And 3 plus 4 is 7, so I have 57.6. That's what was inside the brackets. And now I'm going to divide that by 0.2. So basically I've got 57.6, and we're dividing into that 0.2. Now what did I tell you? In class, we don't want to divide with this number 0.2. We want it to be an integer value. So I'm going to multiply by 10, which is essentially moving the decimal to the right one position. If that moves to the right one position, then this number here also needs to move one position. So when I rewrite this, it's going to be 2 divides into 576, and the decimal is at the end there. Okay, I'm just going to move this out of the way here and give myself a little bit of space. So does 2 go into 5? Yes. How many times? 2 times to be 4. And I have a remainder of 1 and 17. Does 2 go into 17? Yes. 8 times, which is 16. And I now have 16 left over. Does 2 go into 16? Yes. It goes in there 8 times. So that is going to be your final answer, 288. All right, so that is the end of the package, and hopefully you guys have no problem with these questions and you're very successful on the level 6-7 challenge test.